Hello and welcome. In the last lesson, we talked about number bases. We looked at some applications of number bases and solved questions involving number bases. In this lesson, we are going to talk about modular arithmetic. At the end of the lesson, we'll be able to describe the concept of modular arithmetic, be able to list some applications of modular arithmetic, and you should be able to solve questions involving modular arithmetic. Let's get started. Modulo Arithmetic. So modulo arithmetic is a system where numbers wrap around after reaching a certain value. That is, modulo arithmetic is just a system whereby numbers wrap around after reaching a certain value. The numbers, when they reach a certain value, if you are talking about mode 5, for instance, when the numbers go 0, 1, 2, 3, 4, when they get to 4, they wrap around back to 0, 1, 2, 3, 4. When it gets to 4, it wraps around back to 0, 1, 2, 3, 4. That is if you are talking about mode 5, for example. So when the numbers reach a certain value, they wrap around. In such system, we say we are using modular arithmetic. So the modular arithmetic in mathematics, in the operation, it involves finding the remainder after division of one number by another. So in modular arithmetic, it's just the remainder we are tracking. We are not even interested in the quotient of the division. You know, in number basis, at least we are still tracking the quotient. But for modular arithmetic, it's just the remainder. Once we get the remainder once, and we use it, that is all. So the modular arithmetic is the assertion of the remainder of a number. That is what we actually need. What we need is the remainder. We are not really interested in the quotient of the division. For example, if you say 7 in mode 3, it means dividing 7 by 3, which will be 7 divided by 3, that will be 2, remainder 1. So 7 in mode 3 is 1. That's just the remainder. Just the remainder we need, 1. And if you say 14 in mode 5, it means to divide 14 by 5, which will be 2, remainder 4. So 14 in mode 5 is 4. Like I said, it's just the remainder you need, just the 4. So modular arithmetic is used in computer science, it is used in cryptography, and it is used in algorithms. Modular arithmetic is used a lot in computer science and algorithms. If you are trying to perform an operation based on whether a number is an even number or whether the number is an odd number, then you are going to use modular arithmetic for that. Key use of modular arithmetic is in handling cyclic or periodic processes. That is the most important use of that's a key use of modular arithmetic when you are handling cyclic or periodic processes. For example, in places whereby the markets are counted in, maybe markets are counted in 12 days. Okay, so it's when you have markets to the next market day is going to be in 12 days. In such a place, if you are counting the days in 7 days, like we have in a week, it won't really help you to guess what the market days is going to be. To get what the market days is, you have to count it in 12 days. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then you go 0, 1, 2, 3 back again. So in such a case, modular arithmetic are very, very relevant because that is actually a cyclic process. Because after the first 12 days, then you have another 12 days to count before you get to the next market day. So let's now perform some simple operations in modular arithmetic. If you want to solve 17 is equivalent to x in mode 5, that's just simple, right? You're trying to find the value of 17 in mode 5. That's the meaning. 17 is equivalent to x in mode 5. It means you're just trying to find the value of x. You're going to try to find the value of 17 in mode 5. And to do that, you can say it is 17 is 5 plus 5 plus 5, then plus 2. But the easiest way is just to say divide the 17 by 5, which will give you 3 remainder 2. That 2, which is the remainder, is our interest. So 17 equals to x is equivalent to x in mode 5. Just means to find the value of 17 in mode 5. Another example, to solve 5x is equivalent to 8 in mode 6. So if you want to solve 5x is equals to 8 in mathematics normally, what you will do is to divide both sides by 5 and you get 1 remainder 2. But remember that in modular arithmetic, what we are interested in is the remainder, and that remainder must come from division with the modulo, not by any other number. So if you are going to get any remainder here, it has to be when we divide by 6, which is the modulo. So to solve 5x is equivalent to 8, because 8 is not exactly divisible by 5, we have to first take that 8 and convert it to modulo 6. So 8 in modulo 6 is 1 remainder 2. So we say 5x is equivalent to 8. The answer will be 5x is equivalent to 2. Because we got that 2 when we converted the 8 to modulo 6. We have changed 5x is equivalent to 8 to 5x equivalent to 2. 8 is just 2 in modulo 6. So what we'll now do is that we will now bring up that 2 to a value that is exactly divisible by 5, such that when we divide by that 5, there will not be any remainder. And to do that, we are simply going to be adding the modulo to the 2. So we get the first value that is exactly divisible by 5. So if we do 2 plus 6, that will be 8. 8 is still not exactly divisible by 5. Then we do 8 plus 6, that's 14. 14 is not exactly divisible by 5 because it will give us 2 remainder 4. Then 14 plus 6, that is 20. Now 20 is exactly divisible by 5. So if we do 5x is equivalent to 20, when we divide both sides by 5, we get x is equals to 20 over 5. So x equals to 4. 4 will be our solution. Also, if we want to solve 5y plus 3 is equivalent to 2 in modulo 11. Because what we will do first is to transfer the 3 to the other side. That will give us 5y is equivalent to 2 minus 3 in modulo 11. So the 5y is equivalent to negative 1 in modulo 11. So now we have a negative number. How do we handle negative number in modulo arithmetics? What we do to handle negative number is that you add the modulo to that negative number till you get the first positive number. So for negative 1 now, what we do to it is we add the modulo to it. Negative 1 plus 11, that will be 10. That's our first positive number. So stop there. 5y is equivalent to 10 in modulo 11. That 10 is just the same thing as negative 1 in modulo 11. I obtain by 10 by adding the modulo to the negative 1. The modulo is 11 in this case. So now that we have 5y is equivalent to 10, luckily for us, 10 is also divisible by 5. So we just divide both sides by 5. So y is equals to 10 divided by 5. So y is equals to 2 will be the solution. That brings us to the end of the lesson on number basis and modulo arithmetic. As a summary, we've looked at introduction to number basis or radix. We looked at some common number bases used, which are base 2 binary, base 8 octal, base 10 decimal, which is the general base, and the hexadecimal base, which is base 16. We talked about positional notation, whereby we said that the position of the digits in number bases represents their value, and that value is in powers of the base. We talked about converting between various number bases. Then we talked about modulo arithmetic as being used for cyclic events or periodic events, and we looked at concept of modulo, applications of modulo, and of course we solved sample equations. Thank you very much for listening.